Reality Capture, Laser and Photo Reconstruction Workflow, Part 1. Step 1. Import laser scans. Import images. Welcome to the Capturing Reality tutorial on the laser scan and image reconstruction workflow. First, we import and convert PTX laser scans into the internal LSP, laser scanner picture format. Click the Laser Scan button in the Import and Metadata part of the Workflow tab, to import laser scans. Mark all PTX files, and click the Open button. A laser scan import window appears. Let us go through its settings. The registration setting defines the type of the inter-scans relation. With the exact option selected, the imported poses will be preserved. In such case, the imported model defines the scene coordinate system. Choose the draft option when that scanning stations have been registered, but the registration needs to be fine-tuned. The unregistered option is suitable when the stations have not been registered. The registration engine will calculate poses of all scans. Set the georeferenced option to true when your laser scans are georeferenced. This type of data will be then included in your project. When set to true, the coordinate system will also have to be specified. The Features setting enables a choice, whether to use a color, or a laser intensity channel, for registration of photos to laser scans. Color is the default value. The choice of a particular noise profile, for imported laser scans, defines how the point cloud precision changes, with the growing distance from the scanner station, and laser intensity value. The noise-free or scan station P20 profile can be selected. There is also possibility to define your own noise profile, based on your laser scanner technical documentation. To add a new profile, edit the Noise Profiles XML file, which can be found in the Application Executables folder. The Output Path setting specifies a target folder for saving newly generated LSP files. The default option is to store LSP files with original files. Let us select the option Custom to choose our own target folder. The Custom Path option enables you to choose a specific target folder to store generated LSP files to. Now, click the OK button to finish the laser scan import process. During the laser scan import, LSP files are generated. In this case, each 360 by 360 scan is converted into 6 LSP files. Just these LSP files will be needed from this point on. LSP files can later be imported into a new project in the same way as ordinary images. Scan thumbnails are also generated during the laser scan import process. Let us import the images now. Click the Image button in the Add Imagery part of the Workflow tab to add the corresponding images. Mark all images, and click the Open button to load them. Step 2. Align laser scan and image data. Run alignment to automatically compute positions and orientations of images and laser scans. In the Registration part of the Alignment tab, click the Align Images button to align the source data. It has taken just 1 minute and 45 seconds to align all 4 laser scans and 83 images. Let us browse the result of the alignment process a little bit. Click and hold the right mouse button to rotate, and the left mouse button to move the scene in the 3D view. Scroll the mouse wheel to zoom in and out of the scene. Click some laser scanners in the 3D view to display the corresponding LSP pictures in the 2D view. The scene is automatically metric and aligned according to GPS positions of the laser scans. Step 3. Define a ground plane. Set a reconstruction region. Let us define a ground plane to align object in the 3D view with the axis. In the Reconstruction tab, click the Define Ground Plane button in the Model Alignment part to define a ground plane in the 3D scene view. Click and hold the left mouse button on the widget to align the scene appropriately. Click the button again to hide the ground plane widget. Let us create a reconstruction region now. In the Reconstruction tab, click the Set Reconstruction Region button in the Model Alignment part to set the region manually. Define and adjust the reconstruction region by clicking the left mouse button and moving the mouse. Step 4. Browse project details. Change the left 2DS view to the 1DS view, to show the text information on the project. The source data, laser scans and images, are aligned to only one component named Component 0, which consists of 107 registered camera poses, 83 imported images and 24 generated LSPs. Click the Component 0, to show the selected component's info panel. Expand the alignment report, to show more details about the performed alignment. Step 5. Browse settings for laser scan meshing. Click the Settings button in the Process part of the Reconstruction tab, to show the Reconstruction Settings info panel in the 1DS view. Expand the Laser Scans menu, to show settings for laser scan meshing. These settings are used when a laser scan is being used during a model computation. The setting minimal distance between 2 points defines the final density of the laser scan-related parts of a model. The value is set in meters, so the value 0.002 means 2 millimeters, which is enough for this scene. Model parts that come from images can be denser. Use the minimal distance between two vertices setting from the mesh calculation settings to control the overall density of the final model. Points that are further from the scanner position than the value of the set point cloud cropping radius will not be used in a model computation. Use this setting when there is known that distant points have low accuracy, and you do not want to use them in the final model. Use the setting minimal intensity to disable using points with intensity lower than this value. See your scanner specification. Usually, low intensity points are not accurate enough, and you may not want them to be reconstructed. Step 6. Create model in high detail quality. We are ready to create a model from the source data now. Click the High Detail button in the Process part of the Reconstruction tab to calculate a model in high quality. The reconstruction in high quality has taken just 1 hour and 12 minutes to generate a model of 131 million triangles in a 2 mm detail.